evaluates itself. All of those capabilities are now integrated, and you can see it coming out into the marketplace all over the place. Agentic AI is real. Agentic AI is a giant step function from one-shot AI. The one-shot AI was necessary to lay the foundation so that we can teach the agents how to be agents. You need some basic understanding of knowledge and basic understanding of reasoning to even be able to be teachable. And so pre-training is about teachability of AI. Post-training, reinforcement learning, supervised learning, human demonstration, context provision, generative AI, all of that is coming together to formulate what is now agentic AI. Let's take a look at one example. Let me show you something. It's built on Perplexity, and it's super cool. AI agents are digital assistants. Based on a prompt, they reason through and break down problems into multi-step plans. They use the proper tools, work with other agents, and use context from memory to properly execute the job on NVIDIA accelerated systems. It starts with a simple prompt. Let's ask Perplexity to help start a food truck in Paris. First, the Perplexity agent reasons through the prompt and forms a plan. Then, calls other agents to help tackle each step using many tools. The market researcher reads reviews and reports to uncover trends and analyze the competitive market. Based on this research, a concept designer explores local ingredients and proposes a menu complete with prep time estimates, and researches palettes and generates a brand identity. Then, the financial planner uses Monte Carlo simulations to forecast profitability and growth trajectory. An operations planner builds a launch timeline with every detail, from buying equipment to acquiring the right permits. The marketing specialist builds a launch plan with a social media campaign and even codes an interactive website, including a map, menu, and online ordering. Each agent's work comes together in a final package proposal, and it all started from a single prompt. One prompt like that in the original chatbot would have generated a few hundred tokens. But now with that one single prompt into an agent to solve a problem, it must have generated 10,000 times more tokens. This is the reason why Grace Blackwell is necessary. This is the reason why we need performance and the systems to be so much more performant generationally. Well, this is how Perplexity builds their agents. Every company will have to build their own agents. It's terrific. You're going to be hiring agents from OpenAI and Gemini and Microsoft Copilot and Perplexity and Mistral, and there'll be agents that are built for you. And they might help you plan a vacation or, go do some research, so on and so forth. However, if you want to build a company, you're going to need specialized agents on specialized tools and using specialized tools and specialized skills. And so the question is, how do you build those agents? And so we created a platform for you. We created a framework and a set of tools that you can use and a whole bunch of partners to help you do it. It starts with, on the very bottom, the ability to have reasoning models that I spoke about. NVIDIA's Nemotron reasoning large language models are world-class. We have Nemo Retriever, which is a multimodal search engine, semantic search engine, incredible. And we built a blueprint, a demonstration that is operational, that is essentially a general agent. We call it IQ, AIQ. And on top, we have a suite of tools that allows you to onboard an agent, a general agent, curate data to teach it, evaluate it, guardrail it, supervise, train it, use reinforcement learning, all the way to deployment. Keep it secure, keep it safe. that suite of toolkits is integrated, those libraries are integrated into the AI ops ecosystem. You can come and download it from our website yourself as well, but it's largely integrated into AI ops ecosystem. From that, you could create your own special agents. Many companies are doing this. This is Cisco. They announced it yesterday. We're building AI platforms together for security. Now, look at this. AI agents are not one model that does all of these amazing things. It's a collection, a system of models. It's a system of AI large language models. Some of them are optimized for certain type of things. Retrieval, as I mentioned, performing skills, using a computer. You don't want to bundle all of that stuff up into one giant, mass of AI, but you break it up into small things that you could then deploy CI/CD over time. This is an example of Cisco's. Now the question is, how do you now deploy this? Because as I mentioned earlier, there are public clouds where NVIDIA's compute is. There are regional clouds, we call them NCPs. Here, for example, Mistral. You might have something that is private cloud because of your security requirements and your data privacy requirements. You might even decide that you have something on your desk. And so the question is, how do you run all of these? And sometimes they will run in different places because these are all microservices. These are AIs that could talk to each other. They could obviously talk to each other over networking. And so how do you deploy all of these microservices? Well, we now have a great system. I'm so happy to announce this for you. This is called our DGX Lepton. DGX Lepton, what you're looking at here, is a whole bunch of different clouds. Here's the Lambda cloud, the AWS cloud, here's your own developer's machine. Your own system could be a DGX station, Nebius, Yoda, and Scale. It could be AWS, it could be GCP. NVIDIA's architecture is everywhere. And so you could decide where you would like to run your models. You deploy it using one super cloud, so it's a cloud of clouds. Once you get it to work, once you get this NIMS deployed into Lepton, it will go and be hosted and run on the various clouds that you decide. One model architecture, one deployment, and you can run it everywhere. You can even run it on this little tiny machine here. This